Last episode, diffusion learned to create, turning pure noise into an image, but generating is still one shot. What if the whole task is a sequence of decisions, each one changing what comes next, and we only learn how well we did at the very end? Think of training a dog. You can't explain sit in words, you wait for the right move, then reward it. The dog has no labels, only a stream of states, actions, and treats, and somehow it learns a strategy. Reinforcement learning is that loop written as math. We name the pieces. A state is where you are, an action is what you do, a reward is the treat. The thing we actually care about isn't one treat, it's the return, the total reward stretching into the future, with later rewards discounted by a factor gamma, because a treat now beats a treat someday. The value of a state is the expected return if you start there and keep playing, and it obeys one beautiful equation, Bellman's. The value of a state equals the reward you get, plus gamma times the value of the next state. Value today is reward now, plus discounted value of where you land. That recursion is the whole engine. This is RLHF, the step that turned a raw next word predictor into ChatGPT. A reward model scores answers by how much humans like them. Then a policy gradient, pushing the model toward high return actions, nudges every word choice toward answers people prefer. Bellman and policy gradients are how a predictor becomes an assistant. Here's the whole idea in one file, a tiny 3-state chain, and we let the Bellman equation solve itself by repetition. We build the MDP, 3 states in a line, S0 to S1 to S2, and a reward of 1 for reaching the goal S2. Gamma is 0.9. We start with all values at 0 and sweep. Each state's new value is the reward at the next state, plus gamma times that next value. That single line is Bellman, applied over and over. After it settles, we print the values. S1 sits one step from the reward, so its value is 1. S0 is 2 steps out, discounted once, so its value is 0.9, exactly gamma. The figure plots each state's value across sweeps, climbing and flattening as the recursion converges. The printed V of S0 is 0.9000 and V of S1 is 1.000. The discount factor recovered by pure iteration. And that closes the course, from numbers and vectors all the way to a machine that learns to act. Thank you for building this whole stack of math with me. If it helped, follow and subscribe. There's more coming.